Going to talk about the practice problem that was due for class today. Suppose that black hair is dominant over blonde hair and brown eyes are dominant over blue eyes. If the father has black hair, it states that he's heterozygous. So just remembering that hetero means different. And you'll see that down here. He's different for black hair, and for brown eyes, he's hetero as well. So you have a big E, little e right there. And then the mom is, and the mother has blonde hair. Well, we know that that is recessive, so that can only be two little b's. And blue eyes, which are also recessive, so those are two little b's, two little e's. So if we do our FOIL method here, and look at our dad, we have a big B, capital E. That's one possible gamete. Capital B, lowercase e. Then he has lowercase b, capital E. And lowercase b, lowercase e. So those are the four possible gametes that the dad could give for the child. Now the mother, she can give lowercase b, lowercase e, lowercase b, lowercase e. Looking at the second b, lowercase e. Third, second b, second e, lowercase b, lowercase e. So she is like this for all of her possible gamete combinations. Okay, so when we fill in the table, we fill in our parents as is. So again, here's our mom. They're all the same. And dad has four different gametes because of the FOIL method. And then you just combine. So this capital B, capital E will go in the first box. And this lowercase b, lowercase e from the mom also goes in there. And just fill in every box like that until you get all of them completed. And what we're going to notice here is that each of these shaded in areas show different phenotypes. So let's ask the first question is what % of the offspring will be heterozygous? Totally. So that means the B's and E's are heterozygous. So these have B's and E's heterozygous. These do, and these do. All the other ones, like this one is heterozygous for the B's, but not for the E, so it doesn't count. So there is 4 out of 16, which is reduced to 1/4, which equals 25%. What is the phenotypic ratio? Well, all of these have different phenotypes. This is black hair, brown eyes. These are all black hair, blue eyes. These are all blonde hair, brown eyes. And these are all blonde hair, blue eyes. And they're the same for all the way across. So the phenotypic ratio is, there's 4 of each phenotype. 4 to 4 to 4 to 4. But we know that can be reduced to, I would like the answer to be 1 to 1 to 1 to 1. And what % of the offspring will have blonde hair and blue eyes? That is only looking at this section right here, which is 4 out of 16, also known as 1/4, which equals, same problem as kind of up here, 25%. So I like to do things a shorter way, and so this is how I would set up this problem. You can always set it up this way in the 16 grid every single time. But you're going to notice that there's lots of repeats and we have to reduce. So if we want to set it up the way where we don't have to do repeats, is that we have to look at the mom's and dad's foiled genotypes or gametes. So dad has 4 different gametes, so I can't reduce his. But mom, you're going to see, has 4 of the same. So we don't have to put all 4 down if they're the same and repeating. We can just simply use the 1 and then cross off any of the repeats and don't set it up in our table. So initially when you set up your table, it's really just a 1 to 4 grid where this is my mom. Again, I still foiled it, but remember I had 4 different options. I had BE for all 4 of them. So instead of writing 4 across, I just simply crossed off the repeats and I only used 1 for mom. I couldn't do that for dad though, because dads have 4 different. They're all different. So there's none that were repeating, so I couldn't cross any off for him. So what is the percent of offspring that will be totally heterozygous? This section is the only ones that are totally heterozygous, which is 1 out of 4, which equals 25%. That is the same thing that it equaled on this same problem, except I didn't have to reduce it. So then going into this, what is the phenotypic ratio? Well, all 4 of them are different, so it is a 1 to 1 to 1 to 1. And then what percent of the offspring will have blonde hair and blue eyes? These are the only ones that are blonde hair and blue eyes, which is 1/4, which equals 25%. So again, you get the same answers, but you don't have to fill in as much as your table. Again, I would never count wrong for either way if you set up 16 boxes every single time, or if you just reduce it. I just prefer the reduce method because I think it's easier for me to not make mistakes when I'm adding them up and trying to count the phenotypes. Right, so here's another problem, and when I look at this problem, it says summer squash is a white fruit, so it's dominant, so it's capital W, and it has it's dominant to yellow, which is little w, so this is white, and this is yellow. And there's another type, which is the shape of it. If it's a disc shape, it's a capital D, which is disc. And if it's a lowercase shape, it is a sphere shape. So then if we look at the problem itself, the dad, it says is a homozygous white and homozygous disc. So one parent is homozygous for white and homozygous for disc, which looks like this. It's crossed with another parent who's yellow and sphere shaped. So yellow is little w, and sphere shape is little d, little d. So it actually asks you to do 2 crosses, the F1. So we'll start with that one. The F1 cross is looking at when we foil this for dad, the gametes, the only possibilities we have, it's big W, capital D. Big W, capital D, big W, capital D, big W, capital D. So they're all the same. So I don't need to have 4 boxes for it. I can simply just have 1 box for dad. And then mom, they're all the same as well. So she has little w, little d, little w, little d, little w, little d, little w, little d. They're all the same. So I don't need to have 4 boxes for mom. I can simply just have 1 box for mom. And then, so this is just a 1 by 1 grid. I'm going to get big W, big D, little w, little d. And that's what all my offspring will look like for this F1 generation. Now they want you to do an F2 generation of this. So the F2 generation, you're going to have 4 different gametes when you foil it. Big W, big D, big W, little d, little w, big D, little w, little d, for both of them. So that one you can't shorthand it. So you're going to get this. It'll look like this. When you fill it in, this one's going to be white and disc shape. This one will be white and disc shape, white and disc shape, white and disc shape. This one is white and disc shape, white and sphere shape. So I'm going to do a different color for white and sphere shaped, white and disc shape, white and sphere shape. Then we have white and disc shape, white and disc shape. Should be blue. These are all white and disc shape. This one is yellow and disc shape. Then we have yellow and disc shape. Then we have white and disc shape. white and sphere shaped. We have a yellow and disc shape and a yellow and sphere shape. So the last one. So the phenotypic ratio for this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 to 3 to 3 to 1 ratio.